We're going to review a few more just really simple, straightforward trig word problems, mainly like you would see on the ACT test, just so that you can practice setting up your right triangles, turning the words into relationships, picking which trig ratio to use. We're just going to go through a few examples. It'll be a really short, straightforward lesson. So at a point on the ground 50 feet from the foot of the flagpole, the angle of elevation to the top of the pole is 53 degrees. Find the height of the flagpole. All right, so they give us the horizontal distance. They ask for the vertical distance. You can call that Y if you want to. You can call it H for height. You can call it F for the flagpole, whatever you want to do. Just make sure it's labeled where it makes sense. We have an angle of elevation that is 53 degrees, and they want the opposite side height, and they've given us the adjacent side. So opposite and adjacent from SOHCAHTOA is tangent. So we're definitely going to use the tangent trig ratio. So the tangent of 53 degrees would have to equal opposite over adjacent, or H over 50. And then we just solve, make sure you're in degree mode still, we solve for the unknown. If they ask in words, we answer in words. We would say the height of the flagpole is 66.35 feet. Another example. A 20-foot ladder leans against a wall so that the base of the ladder is 8 feet from the base of the building. That's horizontal. The base of the ladder is 8 feet from the base of the building. What angle does the ladder make with the ground? So we know we have a 20-foot tall ladder. That's the hypotenuse of our triangle. And the adjacent side to our angle is 8. And they want to know the angle measure. Well, this is where we're going to have to get into the inverse functions, right? You have sine inverse, cosine inverse, and tangent inverse buttons. They're the second buttons above sine, cosine, and tangent on your TI calculator. So this is something we definitely can do, is use those inverse buttons. So if they want to know the angle measure, then they've given us adjacent and hypotenuse, so that's cosine. So the cosine of that angle measure is going to have to equal adjacent over hypotenuse. If we want to solve for the angle measure, we're going to have to take the cosine inverse of the side ratio, and that will give us the angle measure. So the angle is 66.42 degrees, or the ladder makes an angle with the ground of 66.42 degrees. At the circus, a person in the audience watches the high wire routine. A 5-foot 6-inch tall acrobat is standing on a platform that is 25 feet off the ground. So we have the platform, and then we have the acrobat. So 5.5 feet. 5.5 is 5 foot 6 inches. How far is the audience member from the base of the platform? If the angle of elevation from the audience member's line of sight to the top of the acrobat is 27 degrees. So we want to know this horizontal distance. How far is the person in the audience away from the base of that platform, with the angle of elevation is 27 degrees. So again, we have opposite over adjacent, so that is tangent. So just use good mathematics. We're going to multiply both sides by x. That gives us x times the tangent of 27 degrees equals 30.5. Then we're going to divide both sides by tangent of 27 degrees. And then that's just numbers. We get that accurate to 4 decimal places. And the horizontal distance is 59.9 feet. All right. At a diving competition, a 6-foot tall diver stands atop a 32-foot platform. So there we are. 32 foot plus 6 is not 37. I don't know where they got 37 from. That's 38. Let's try that again. The front edge of the platform projects 5 feet beyond the ends of the pool. So the pool itself is 50 feet in length. So we've got to take that 50 feet and subtract 5 feet, because the platform is 5 foot over here in this direction. Camera is set up at the opposite end of the pool, even with the pool's edge. If the camera is angled so that its line of sight extends to the top of the diver's head, what is the camera's angle of elevation to the nearest degree? So they have given us the the horizontal distance and the vertical distance. This may not be right now since that's actually 38 and not 37 like they had listed, but it's opposite over adjacent. So we're going to use the tangent of x equals 38 over 45. So the tangent inverse of 38 over 45 is going to give us that x degree measure. Let me use my calculator really quickly and let's see. So I want the tangent inverse of 38 divided by 45, and that's 40.17. So let's change that. That's 40.2 degrees. All right, one more example. A roller coaster car is at one of its highest points. It drops at a 63-degree angle for 320 feet. How high was the roller coaster car to the nearest foot before it began to fall? Here's something that can be kind of confusing. Let me see if I can. Here's the horizontal. And so this is actually talking about here is 63 degrees. But notice that the base of this triangle and that horizontal line are parallel to each other. So we have alternate interior angles there. So whatever this angle of depression is here, as long as these two things are parallel, then the angle of angle of depression and angle of elevation are going to be the same. So it's perfectly okay to say that this is your 63-degree angle. And it traveled for 320 feet. How high was the roller coaster car to the nearest foot before it began to fall? So it's asking for h. So we have an angle, we have opposite, and we have hypotenuse, so we're going to have to use the sine function. So the sine of 63 degrees equals h over 320. So h would have to equal 320 times the sine of 63 degrees. I get 285.122. So to the nearest foot, that's 285 feet above the ground. I know those were simple and straightforward examples, but I just wanted to make sure that we had a little bit more practice. The ACT trig word problems seem to be as straightforward as these are. So come to class next time. We'll practice some released trig ACT word problems.